In this video, we will begin Chapter 7 by talking about congruent triangles and similar triangles. So hopefully you remember some things about congruent triangles and similar triangles from elementary school, but really one simple way of looking at it is that congruent triangles are two triangles which have the exact same size and exact same shape. Now, similar triangles, there are two triangles which have the same shape, but not necessarily the same size. Now, so going back to congruent triangles, if they have the same shape and the same size, what you can also say is that the corresponding sides are equal in length. And the corresponding angles are congruent. So let's talk about what corresponding sides and corresponding angles mean. So if we look at this triangle here, okay, with these two triangle ABC and triangle XYZ, okay, so angle A is congruent to angle X, okay, as you can see from the diagram. So guess what? Angle A and angle X are corresponding angles. And angle B is congruent to angle Y, so we say these two angles are corresponding. And lastly, of course, we can say angle C corresponds to angle Z when we're talking about these two congruent triangles, okay? So the notation we're going to use is say triangle ABC is congruent to triangle. Now, you can, if you're talking about triangle XYZ, you can say YXZ. You can say ZYX. You can say XZY. But because you want your notation to show the corresponding angles and the corresponding sides, so if you say triangle ABC instead of, let's say, CBA, then what you have to do is, if you start with A, you have to start with X, because angle A is corresponding with angle X. And if the next letter here is B, then you have to put Y here. And then of course you have to put Z. So that's what corresponding means. And then of course you have a corresponding side. So AB is corresponding with XY. And so AB, the side length of AB, or side AB, corresponds to side XY. Side AC corresponds to side XZ. And then BC corresponds to YZ. Okay. Now, similar triangles, once again, they have the same shape but not necessarily the same size. Now, similar triangles, their corresponding angles are also congruent. Okay, so that's the same as what we said with congruent triangles. But the difference between similar triangles and congruent triangles is this point here. Corresponding sides are proportional. Corresponding sides are proportional. So we're going to see what I'm going to write in the next. I'm going to write then on the next page. But what does corresponding sides being proportional means? So let's just start off with talking about the corresponding sides. So AB. Okay, if you look at the angles, AB, the corresponding side with AB is XY. Okay, so let's do XY over AB. Whatever XY over AB is must be equal to, let's do XZ over AC. Okay, that's what corresponding sides are proportional means. So corresponding sides, if you take a ratio of the corresponding, that ratio will hold true. And let me just write the last ratio and then we'll talk about it again. So let's do YZ. YZ is equal, YZ over BC. Okay, so these three ratios, of course, are equal. So a simpler way of saying it is like when you're playing with a toy or a model car. It's a scaled down version of the actual object. So let's say triangle XYZ is all the side lengths are twice the length of the side lengths of triangle ABC. So that means the ratio here would be 2, right? So I don't know what the length of side length XY is. I don't know what the length of AB is, but the ratio is 2. And if this ratio is 2 and the triangles are similar, then these ratios must also be 2. Okay, that's what it means for two triangles to be similar. The corresponding sides must be proportional. If this is true, then the two triangles must be similar. Okay, and if the corresponding angles are congruent, then it must be similar. I don't know if they're congruent, but I definitely they're similar. Okay, so let's the big idea in this lesson is actually first of all, you need to know what it means, or what's true, what facts are true about the two triangles when they are congruent or similar. But the big idea we're trying to get after is trying to prove that two triangles are similar or two triangles are congruent. So what we're going to do is look at this piece of paper here, which shows us different ways to prove that two triangles are similar or two triangles are congruent. So let's say I have triangle ABC and triangle XYZ. These two triangles are similar. This is one way of proving the fact that they are similar, using side similarity. So if I'm given all three sides of triangle ABC and triangle XYZ, if I see that the corresponding sides are proportional, just like what I showed earlier, then guess what? The two triangles must be similar. Okay, what about this one? Side, angle, side. So if I showed that, okay, I call this a sandwich situation because you have side, angle, side. So it's like your angle is being sandwiched in between the two sides. So if you have a side, angle, side situation, which means these two sides, the corresponding sides, so okay, let's say I wrote it down. So AB over XY is equal to BC over YZ. So I've shown that these two sides, so let's say AB and XY, BC and YZ, those two corresponding sides are proportional, and the angle in between those two sides, so in this case angle B is congruent to angle Y, then I've shown, or if that is true, I have shown that these two triangles are similar. Okay, so there's side similarity, and now this is called side angle side similarity. Okay, the last one is actually the most common way, I guess, for most of our examples to prove that two triangles are similar. It's called angle similarity. Really straightforward. Okay, so if I have two corresponding angles are congruent, then that's sufficient to prove that the two triangles are similar. So if I've shown that angle B is equal to angle Y and angle C is equal to angle Z, guess what? These two triangles are congruent. Now, by the way, if the two angles here, if the two corresponding angles are congruent, guess what? The third angle must also be congruent because the sum of the interior angles must be 180 degrees. So if all three angles, all three corresponding angles are congruent, then guess what? Back to what we said here, right? If all three angles, corresponding angles are congruent, then the two triangles must be similar. So you don't need to show angle similarity. Just two angles is good enough. Okay, let's keep going. So now what we're going to do is we are going to prove for congruence this time. Okay, so this one is called side congruence. Okay, so instead of saying all three corresponding sides are proportional, we show that all three corresponding sides are equal in length, then that's sufficient to prove that the two triangles are congruent. Okay, and then we have side angle side congruence. So this one, just like before, the sandwich situation, but instead of saying the corresponding sides are proportional, you're saying the corresponding sides are equal in length. Then you've proven that the two triangles are congruent. Okay, we have angle side angle congruence. Ooh, okay. So this is, yeah, really it's just angle side angle, angle side angle. So if you have, I guess, these two angles here and their corresponding angles are congruent, and this side BC is the same length as YZ, that's sufficient to show that the two triangles are congruent. Okay, really just follow the letters. Like if you say angle side angle, it really is. And then you look at the diagram, angle side angle. It's really that straightforward. Once again, if two of the two pairs of corresponding angles are congruent, then of course the third angle must also be congruent. Okay, last one here, we have angle side. Okay, so just don't confuse this one with angle side angle. So angle side, angle, angle, side. All right. Remember, if you're trying to prove that the triangles are congruent, the pairs of sides, the corresponding sides, in this case B, C, and Y, Z, they are not proportional in length, but they are equal in length. Okay? So we have 4 ways to show that 2 triangles are congruent, and we have 3 ways to show that the two triangles are similar. All right, so now let's run through the pairs of triangles and show or say whether they are similar or congruent or neither. Okay, so is this triangle ABC and triangle XYZ, are they congruent? Definitely not. Okay, I'm looking at the side lengths, they're very different. Okay, so the question is it similar? So what am I gonna do? I'm gonna do some math over here. I'm gonna look at the 3 sides. I'm gonna the largest sides, and then the middle length, and then the shortest length. So I'm gonna see if they're proportional. So 4.5 over 3. Okay. Let's say 4.5 over 3. You don't need a calculator, but I'll just show anyways. 1.5. I'll do the other ones using a calculator. So 7.5 over 5. Ooh. And then 10.5 over 7. Ooh. So, okay, no, I'll just write it. 7.5 over 5. 10.5 over 7. Okay, so these 2 triangles, hopefully you notice that you can say that they are similar now. And how did you know they're similar? What condition was satisfied? And it was side, side, side similarity. Okay, and if that was not enough for you, you can say xy over AB is equal to xy, so we're doing big over small, so xz over AC, big over small, so yz over BC. Okay, we're going to add the fact triangle ABC is similar to triangle, remember, corresponding corresponding angles. So ABC, that has to be XYZ. Okay, all right, so let's see these 2. Okay, so these 2, ooh, this is not proportional. These are exact same lengths, so we're going to say these are congruent triangles. So what's the notation we're going to use? So let's do triangle, let's do LMN. If it's LMN, that has to be PRQ. Okay, right? The angle 70 degrees, 70 degrees. So M and R, perfect. And then PR, LM, perfect. Okay? Really watch the order of the letters. It makes a huge difference. Okay, and now let's see, what's the rationale here? So, ooh, it's our sandwich, right? You see this angle? It's sandwiched between the 2 sides here. So it's side, angle, side, congruence. Okay? You can say, okay, you know what? Let's write it down. So LM is equal to PR. And what else do you know? MN is equal to RQ, and then angle M is equal to angle R. Okay, so that's how we know it's side, angle, side congruence. Okay, so now let's try to prove triangle JKL and triangle DEF. So you know what? I don't know any side lengths, so I can't really say they are congruent, but you know what? I can definitely say they are similar. Okay, and now I'm going to first say they're similar. So similar. So we're going to say triangle, I don't know, let's say JKL is similar to triangle, now it has to be EFD. How do I know that the two triangles are similar? Because I'm told, or I'm given angle K is congruent to angle F, and angle L is congruent to angle D. So you have angle, angle, similarity. Okay? This is, like I said before, it's the most common way when we work with the questions later on. It's the most common way to show that the two triangles are similar. It's so easy, right? You just need to show that two pairs of corresponding angles are congruent. All right, what do we have here? Let me look at the 468, 468. Guess what? Congruent. Congruent. So let's practice triangle. The first one, I don't know, let's either do LKM or let's do alpha order. JKLM. Okay, it's congruent. So KL, we're looking at KL, so this would be TR, right? TRS. Let's check. So KL and TR. Okay, LM and RS. Yep, perfect. Okay, so how do I know? Because KL is the same length as TR, LM is the same length as RS, and KM is the same length as TS. So we have side, side, side congruence. Okay. Oh, what do we have here? Oh, these are not. These are not necessarily. They're definitely not congruent. But are they similar? Okay, you can't just say they're similar. Not necessarily similar. So what we have to do is check the ratios. Okay, let's see. So let's do 12 over 9, 8 over. Yes, they are. Okay, so they are similar. So let's say triangle PQR. Oops, similar. Similar to triangle, let's see, TUV. TUV. Okay. So that's because PQ over TU is equal to QR over UV. And angle Q and angle U are both right angles. Okay, so this is the side angle side similarity. I call this the sandwich. Whenever I see side angle side, I think of a sandwich. Okay, last one. All right. So this one, these two are equal. So AB and CD are equal in length. And hopefully remember, these two are congruent, and the rationale or the reasoning is angle, side, angle, right? Angle, side, angle. This is not the sandwich. It's not side, angle, side. Look at where the given side is, right? So yeah, it's definitely not side, angle, side. Please don't get the two confused. Congruence, so triangle ABC is congruent to triangle, let's see. So A was here, and then B, so B, CDA. We'll double check after. CDA, ABC. Yep, perfect. Okay. So how did I know? Once again, you can start off with saying AB is equal in length to CD, and angle B is equal to angle D. Now angle A, be careful, I'm going to write angle BAC. Angle BAC is equal to DA, sorry, one more time, BAC DCA. Alright, so angle, side, angle, congruence. Okay, so the big idea of the lesson is to know what's true about two triangles which are congruent and two triangles which are similar. So of course, knowing when the corresponding sides are proportional, or knowing when the corresponding sides are equal in length, and then reviewing the different ways to show that two triangles are similar or two triangles are congruent.